Hello everybody, what's up? It's your boy, and I'm here with the first of many videos that you'll be watching if you're taking CCP Physics. So, this is kind of a preliminary assignment, this summer work that I'm going to be giving everybody over the course of this summer. It is mostly just math review. It should be kind of a light warm-up, light jog, if you will, for those of you who are taking CCP Physics next year. So excited. Basically, this is a run-through of a lot of the types of math that we're going to be doing in CCP Physics. It's also going to serve as a way, a kind of introduction video to the way that I'm going to be structuring a lot of the class. So, first things first, this assignment itself is a review of math, different math that is going to be common in physics. Like I said, it shouldn't be too bad for you guys. It should be mostly stuff that you have to look up and remember from previous years. If you don't immediately remember it, that's fine. But it should be look familiar to you. This video here is going to be a guide for me going through this and explaining the answers. Usually when I do this, I will change the numbers so that you can't just like skip to the end and copy down an answer. You have to actually like do the work. But basically often when I assign homework problems, I will accompany it with a video of me solving the same problem effectively with different numbers. That way you can understand the method and check your work without actually, having to getting to just get the answer and not actually be forced to do it, right? So whenever I assign homework, whenever I assign problems to be done on your own in my class, I will often accompany it with a video of me going through effectively the same problem with different numbers so that you have a guide. And of course, you can always ask me questions in person too, but this is a way of kind of making homework better and more conducive to you actually learning, right? Because a lot of the time you'll get homework, not know what to do, and just be kind of stun-locked. Okay, so a lot of the time when I assign problems to be done on your own, they will be accompanied with a video that is like this one. One last thing before we get started, I want to show you, talk specifically about this clause here in my foreword that I wrote at the beginning of this packet here. If you have trouble with this, like really have trouble with this, like this math is not familiar to you, or you find yourself like kind of not being able to follow along with me, that's okay. However, physics is a lot of math, and you kind of can't start doing the physics like your ability to do the physics will be compromised by your struggle with the math. So if any of this is a little bit beyond you or you're worried about, that's okay. Come talk to me and we will discuss options. Maybe you need a little bit of extra help. Maybe you need a little bit of more practice to do. I'd be more than happy to help you with any of that. Likewise, maybe you would want to switch into honors from CCP or, vice versa or whatever, right? So that's a conversation we can have at the beginning of next school year. So please, if you found this hard, any part of this hard, beyond like, needing to remember a formula or something, please come and talk to me and we will try to get you sorted out. Okay? So without further ado, let's get started. Last thing before we begin, there is a method that I recommend using videos like this for, and that is try the problem on your own first. And if you struggle, you can watch the solution to see if there's a mistake you made, or you could just skip around to the video to specific problems, or you can skip to the end and check your answer. In the case of this this assignment, I am going to be using the same numbers, even if usually I change them around in my solutions. Okay, so without further ado, let's get started. Okay, hi. It is Digital McComb. I'm here really quick with the solutions to the first part of our math review. Okay, so first step is going to be pretty simple. We want to find the missing side of each of the following right triangles. In this case, we have two sides of a triangle and one side that is unknown. So we're going to be using Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, where a and b are your two short sides. The order of those does not matter, and c is your hypotenuse. So this is pretty simple. We're just going to fill this in and then go for it. So let's take a look at our first question. We have a right triangle here. We want to know the missing side. So we're looking for the hypotenuse. That's C. These two sides are A and B. So really quick, A is going to be 40. I shouldn't put that there. I should put it here. A is going to be 40. squared plus b is going to be 25 centimeters squared equals c squared. Okay, and now it's just algebra, pretty easy. So a squared is going to be 40 squared, which is 1,600, plus 25 squared is like 625, I think. I'm going to double check on a calculator. 625 equals c squared. Okay, now solve this for c. 1,600 plus 625 is going to be 2,225 equals c squared. Solving for c, we're going to take the square root of both sides of this. C equals the square root of 2225, which is, of course, 47.16 according to my calculator. So something that you will learn when you take my class is that I do not care about rounding numbers at all. I am a physicist. Physicists like to come up with functions and then have a computer do the math when you get to harder questions. So honestly, if we're not in a situation that demands precision, I kind of do not care how you round your numbers. So you could call this 47.16 if you wanted to. You could call this 47.1699 if you're a lunatic. You could call this 47. Honestly, I would be fine with that. I will grade you based on whether or not your math is correct. As long as your final answer is close, I kind of don't care. So in this case, I'm just going to call this 47.2. Round to one decimal place. But I would accept 47. I'd accept 47.16, 169, whatever. Okay, so there is our answer. C is 47.9. And these are in centimeters, so that's going to be in centimeters as well. Okay, next question, same idea. We have short sides being A and B, that one is C. So the relationship is A squared plus B squared equals C squared. That means that A squared plus B is 5 squared equals C is 8 squared. A squared is going to be A squared. 5 squared is 25. 8 squared is 64. Subtract 25 from both sides to get the A by itself. We get A squared equals 64 minus 25 is 39. So A squared is the square root of 39, which, according to my calculator, is going to be 6.24. Let's call it 6.2. And those are in meters, so that's in meters. C, same idea. Let's do this one in pink. We have our two short sides, A and B. Our diagonal, our hypotenuse, is going to be C. We're looking for A again in this case. A squared plus B squared equals C squared. A is an unknown. B is 2.3 equals C is 7. 7 squared is 49. 2.3 squared is going to be something in my calculator. It's going to be like 5 and some change probably. 5.29, let's call it 5.3. Plus A squared. Oopsie. Right? So solve this for A. We're going to subtract 5.3 from both sides. We get A squared equals 49 minus 5.3 is going to be 42.7, right? 43.7. Square root both sides. 43.7. Square root of that, according to my calculator, is 6.6. So A equals 6.6. Those are in meters, so it's in meters as well. Easy peasy. All right. So with that out of the way, let's go ahead and erase this and then move on to the next question. So in the next question, we have the sides Y and W. So I've given you an angle and a side, and I want to find the third side. So here we're going to use our trig identities. Sine, cosine, and tangent, SOHCAHTOA, if you will. So sine of an angle equals hypotenuse over, equals opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite over adjacent. Okay, so in this first question, I'm given an angle. I have its opposite side and its adjacent side. The opposite side is the one that it does not touch. The adjacent side is the one that it does touch. The hypotenuse is the diagonal. Okay, so looking at this, the two pieces that I have are the hypotenuse. I want to know the adjacent, and I've got the angle. So I'm going to choose for this the one that involves adjacent and hypotenuse, which is cosine. Okay, so I'm going to say that the cosine of 58 degrees equals adjacent over hypotenuse, which is my unknown side, y, and my hypotenuse 32.3. Okay, so cosine of 58 is going to be a number between 0 and 1, which again represents the amount that my line is in the x, in the x and in the y. In other words, cosine is going to show me how big this should be relative to how big this is, because I know this angle. Okay, so all I have to do is put that into a calculator. Cosine of 58 degrees, make sure your calculator's in degrees for this, is always going to be a number between 0 and 1. 0.53 equals y divided by 32.3. Solve this for y. We're going to multiply both sides by 32.3. That cancels here. And we get 32.3 times 0.53 is 17.1 equals y. So y equals 17.1, and it's in meters because those are in meters. Excellent. All right, same idea with b. We're going to do the same thing again. Let's do this one in green. Okay, so I've got my angle here. I've got my two short sides, and I've got my hypotenuse. This long diagonal one is my hypotenuse. It's across from the right angle. So that's hypotenuse. This one is going to be adjacent to the angle. It's next to it, right? This 20 is touching it. Over here is the opposite side. So I want to know my hypotenuse, and I'm given my adjacent side. I'm going to use cosine again. So cosine 20 degrees equals adjacent over hypotenuse, which is 17 divided by unknown variable w. Solve this similar to the last one. Cosine of 20 degrees is a number between 0 and 1 in a calculator. So cosine of 20 is 0.939, let's call it 0.94, equals 17 divided by w. We're going to solve this for w, so we want it in the numerator. Multiply both sides of this by w. That cancels here. We get 0.94 w equals 17. Divide both sides by 0.94. W equals 18.09. Let's call it 18.1. And W is, these are in millimeters, so that's going to be in millimeters as well, 18.1 millimeters. Okay, easy peasy. All right, next up, I want to find the measure of the angle theta in degrees or radians for each of the following right triangles. Okay, so let's do that. I have theta here and theta here for each of these triangles. I need to figure out what sides I'm working with here. So this theta, the side that touches the angle, is the adjacent side, that's this one. The side that is across from it is the opposite side, and then your diagonal is your hypotenuse. Okay, so there we go. Now, in this case, I want to know theta. I am given this side and this side, my opposite and my adjacent, so we're going to use tangent. So I could say that tangent to the negative first of my angle is equal to opposite over adjacent, which is 3.6, divided by 6.2. Okay, so now, why is this negative tangent to the negative first? Remember, a trig function turns an angle into a number, a ratio. An inverse trig function will turn a ratio back into a number. So if I know the two sides here, I can get the angle by doing that trig function in reverse. I'm going to pass it over to Flush McComb to show you guys how to do that. Okay, hey, what's up? It's your boy Flush McComb. So we're looking at how we get a inverse trig function into a calculator. Basically, like I said earlier, we have this, and we want to turn this into a angle from a number. So what you're going to do is you're going to do tangent to the negative first power. Oops. Anyway, so we're going to turn this ratio here into an angle, and we do that on one of these calculators by doing shift tangent to get tangent to the negative first, and then you just put in parentheses what you want. So 3.6 divided by 6.2 in our case, and we get 30.1. For my calculator's in degrees, so that's in degrees. This is 30.1 degrees is the answer. Okay, and if you wanted to do this for cosine or sine, you just do shift cosine. Oops. Shift cosine for inverse cosine, and then you put your stuff, let's say 3.6 divided by 6.2 again, into your parentheses like that. For sine, you do shift sine, inverse sine. Basically, whenever you have a number or a fraction that you want to turn back into an angle, you put that in reverse into your calculator like so. Mine works like this. Yours probably works a little bit different, but the point is whatever series of button presses gets you to sine to the negative first, cosine to the negative first, tangent to the negative first, that's what you want to do. Thanks, Flush McComb. You guys might have noticed that arrangement was a little bit different. That was from a previous take that botched with no sound. So this is actually my second time recording this entire thing because I forgot to turn my microphone on like a very smart guy. In any case, so there we go. That's how we get it. Similarly, on this next example, we have our angle here. We have our side here and side here that we're looking at. So adjacent is going to be the one that's next to this. Opposite is going to be the one that's across from this. So that's adjacent, that's opposite. And then hypotenuse is going to be our diagonal, which is this one here. So I have my hypotenuse, I have my adjacent. We're going to be using the trig function involving the adjacent and the hypotenuse, which is, of course, cosine. So I can say cosine to the negative first of theta equals adjacent over hypotenuse, which is 56 centimeters, divided by 72.9 centimeters. I'm going to go second cosine, parentheses, 56 divided by 72.9, close parentheses, bang, there we go, 39.8 degrees. Easy peasy, you'll love to see it. Okay, so let's look at the next question. I want to find the measure of x and b for each of the following right triangles. This is a similar process to what we did a couple questions ago. I have my angle, I have my two sides. I want to find a side given a side at an angle. So I've got this angle here. I've got its adjacent side here. I've got its opposite side here. I've got its hypotenuse here, the diagonal. Okay, so I want the opposite. I have the hypotenuse, I have the angle. Opposite and hypotenuse is going to be sine, so I can write this as sine of 47 degrees equals opposite over hypotenuse, x over 29. Sine of 47 is going to be a number between 0 and 1, 0.73. 0.73 equals x over 29. Multiply both sides of this by 29 to get the x by itself, and we get 21.2. Oops, that's not the hypotenuse. This side is 21.2. And that's in centimeters, so this is going to be in centimeters as well. Great. All right, same idea for the next one. Here's my angle, 35. Here's this side. This side is touching my angle, so it's the adjacent side. This side is across from the angle, so it's opposite. That's the hypotenuse because it's the diagonal. Remember, if you want to remember which one is your hypotenuse, it's kind of hard when your triangle is all flipped around. It is always across from your right angle like this. That's how you can tell easiest what your hypotenuse is. So like that, across from the right angle. Okay, so we got our adjacent side. We want our opposite side. Opposite and adjacent is tangent. Oopsie. So I can say tangent of 35 degrees equals opposite over adjacent, which is b over 0.39 meters. Tangent of 35, my calculator will tell me what that is. That is 70, or sorry, 0.70, excuse me. So 0.70 equals b, not 6, over 0.39. To solve for b, we multiply both sides by 0.39. Multiply by 0.39. That cancels here. B is going to be equal to 0.27 meters. All right, easy peasy. Next question. Find the measure of the angles theta and x in either degrees or radians for each of the following right triangles. Okay, similar to what we did a minute ago. I have this angle, I have this side, I have this side. Let's figure out what those are. This side touches, so that one's adjacent. This side doesn't touch, so it's opposite. This side is our diagonal, so it's the hypotenuse. Okay, so I've got my hypotenuse, I've got my opposite side, I don't know my adjacent. Hypotenuse and opposite side is going to be sine, right? Sine is opposite over hypotenuse. So sine of theta is going to equal opposite over hypotenuse, 4.9 over 7.8. And because this is getting an angle from a ratio, I'm looking for an angle here, it's going to be the negative first. So I'm going to go sine to the negative first on my calculator, 4.9 divided by 7.8, all tucked into parentheses, and I get 38.9 degrees. You can call that 39 degrees if you want. I'm not going to worry too much about it. Okay, same idea over here. Let's use this lighter blue. I'm looking for this angle. I've got this side and this side. This is my adjacent. This is my opposite. This side here is my hypotenuse. I want to know, I know my opposite and my adjacent. I want to know this angle here. So opposite and adjacent is tangent. So I write this as tangent to the negative first of x equals opposite over adjacent. Now, here's the kicker. 97 centimeters and 1.28 meters are not in the same unit. So if I want to get this into the right format, I need to convert them both to be the same. So I could either make this into centimeters or I could make this into meters. You'll get the same thing either way. I'm going to go ahead and make this into centimeters. This side into centimeters. So 1.28 meters, 100 centimeters is a meter, so that's going to be equal to 128 centimeters. Okay, so now that I've got that, we're good. I can do opposite over adjacent now. That is 97, oops. That is 97 divided by 128. Tangent to the negative first of 97 over 128. So second tangent, 97 over 128. 37.2-ish. Sounds good to me. Okay, let's look at the next example. Here I've got a hypotenuse that I've given you and an angle that I've given you, and I want you to find the two sides of this right triangle as a result. This is something that we do all the time in physics. We call this splitting components. Basically, whenever we get a diagonal line, we want to be able to split it into an x and a y component into two straight lines. So given an angle and given a long side, you should be able to get your two sides. Okay, so same idea here. This is my angle, this is my hypotenuse, this is my opposite side, this is my adjacent side. Okay, well, I want to know opposite. I have hypotenuse. Let's start with y first. You could do these in either order. So I have opposite. I want my hypotenuse, or sorry, I have my hypotenuse, excuse me. I want opposite, and I've got my angle. So opposite and hypotenuse is going to be sine. I could do sine of 25 degrees equals opposite over hypotenuse, or y divided by 18. Okay, sine of 25 degrees is 0.42 equals y divided by 18. I want y, we multiply both sides of this by 18. Get that out of the denominator. We get y equals 0.42 times 18, which is about 7.6 meters. And for x, same deal. That's my adjacent, that's my hypotenuse. It's going to be the same process, but with sine, or with cosine, right? So I can say cosine of 25 degrees equals my adjacent over my hypotenuse, which is x over 18. Cosine of 25 degrees is going to be 0.91. 0.91 equals x over 18. Multiply both sides of this by 18. That goes away, and we get x equals 0.91 times 18, which is 16.3 meters. And there we go. And just to check, if this angle is under 45 degrees, which it is, this side should be longer than this side is. And it is, so that's good for us. Okay, great. And then this next one you solve exactly the same way. I'm going to go ahead and run through that really quick. So this is the adjacent side. This is the opposite side. This is the hypotenuse. I want the adjacent and opposite, so that's going to be opposite is sine. So sine of 61 equals opposite over hypotenuse, which is 347. Adjacent is going to be cosine 61 equals y over 347. And then we solve that the same way, right? So sine of 61 is 0.87 equals x over 347. Multiply both sides by 347. It's like 303-ish meters. And then y is the same way. Cosine 61 0.48 equals y over 347. Multiply both sides by 347. That goes away here. 0.48 times 347 is 168.2. And it's in meters because the rest is in meters. And if you think about it, 61, if this angle is big, this side should be longer than this side, which it is. So a good check there. All right, see you in a minute for the circles. Okay, let's talk circles. So you guys probably remember from previous classes that the circumference of a circle is pi times its diameter. In fact, the number pi is the ratio of a circle of a circle's diameter to its circumference. Basically, it should make sense. The longer this line from edge to edge of the circle is, the bigger your circle is going to be, right? A gigantic circle will have a long line. A tiny circle will have a little line. That ratio of distance of the circle to the circumference around the circle. In other words, like imagine if I had like a string, right? If this string is, let's say, 1 meter long, the string going around the edge would need to be 3.14 meters long. So that's where the number pi comes from. And actually, a bunch of different ancient cultures, the Aztecs, the Egyptians, the Greeks, Imperial China, North Saharan Africa, all of these different cultures came up with this idea, right? Humans have known that pi is about 3 is the ratio of a circle's diameter to its circumference. So that's how we find circumference. That's easy enough. The formula for area, the proof for is a little bit harder to remember. It involves calculus, actually, but it's equal to pi times the radius of your circle squared. So radius is half of your diameter, of course. So you could also, if you wanted to be annoying about it, right, that is pi, d over 2 squared, like so. Okay, so circumference and area of the following circles ain't no thing. Here I've got a radius of 5, right, meaning my diameter is going to be double that. So diameter is 10. So the circumference is going to be pi times 10. So your circumference is like 31.4 meters. And your area is going to be pi r squared. So that's pi times r squared, which is 5 squared. 5 squared is 25. Area is pi times 25, which is going to be like a little over 75. 78.5, sounds good to me. And that's in meters, so is the area. And in fact, because this is meters and we're going to an area, it's going to be square meters or meters squared. Another way you can think about this is area equals pi times 5m squared. Both the 5 and the m get squared, so it ends up in square meters. Okay, similarly, same idea with the previous one. If the diameter of this circle is 18, the radius is going to be 9, half of that. So same idea, circumference is going to be pi times diameter. So pi times 18, which is 3.14 times 18. 56.52, let's call it 56.5. And that's in centimeters, so this will be 2. And then, of course, pi r squared is going to be a equals pi times 9 squared. 9 squared is 81 times pi. I can rewrite that as pi times 81, which is 254.34. Let's call it 254.3. And that's in square centimeters. Okay, so easy peasy. Now let's take a look at the next part. We want to find the arc length of a circle. There's actually a couple of ways you could do this. I like to do this kind of the simplest way, the caveman way, if you will. Let's erase my formulas really quick here. But I want to find the arc length of a circle, right? So I want to know what this arc here is, what this arc here is, and what this arc here is. Basically, if I had like a string or something, I want to see how long the string needs to be to go from here to here in this curve, or from here to here in this curve, etc. So how we would do this is pretty simple. I would consider this the easiest way of doing this, to consider this in fractions, right? The whole circumference we know is pi times the diameter. And if it's a unit circle and the radius is 1, that means that the diameter equals 2. Okay, so circumference is pi times diameter, and this is some fraction of the entire circle, right? The circumference is for the whole circle. All I would need to do is figure out what this fraction of that circle is, and then I can figure out what this fraction of the circumference is. So 35 degrees is what fraction of a whole circle? Well, the whole circle is 360 degrees, right? So I can say 35 divided by 360 is 0.097. So 9.7% of the whole circle. And then I can just multiply that by the circumference, and that gives me my arc length, right? So the circumference is going to be 2 times pi, which is 6.28. So arc A is going to be this times the whole circumference, 6.28, and that'll give me my arc length. There are actually a couple of ways you could do this. This is probably the easiest one, I think. It's the easiest way to think about it to me. 0.61. I didn't give a unit. It's fine. 0.61 units, right? So there's that. Same idea for B. 70 degrees is what fraction of a circle? So 70 degrees over 360 degrees is equal to, it's 0.194, 19.4% of a circle, 0.194. And then multiply that by the whole circumference. That way I'm getting just this part. Times 6.28. And that'll be 1.2. 2 is fine. And then for C, same idea. 65 degrees is some fraction of the whole circle. 65 degrees over 360 degrees is 18.05% or 0.1805. Let's call it 0.18 is fine. And then multiply the whole thing by 6.28. $1.13 for that arc. Okay, easy peasy. Again, easiest way I can think of this is find the circumference of the whole thing, which is just going to be our diameter, 2 times pi, and then find the fraction of that the arc is, and then divide out. You can use the equation for arc length too. In fact, if you do this, it will. Come out to be the same thing. This is what the arc length equation is derived from. Okay, so, dimensional analysis. Let's go. So, question 9. Widely believed that Germany's Autobahn highway has no speed limit, has a regulated speed limit of 130 kilometers per hour or less. Some spaces 60 kilometers per hour. We want to convert that into miles per hour. Okay, so we're going to start with 130 kilometers in 1 hour, like so. That's a fraction. I'm going to make this into the grid. Okay, so I want hours in the denominator. I want to leave this as miles per hour. So per hour means I'm going to keep this part the same. So now all I have to do is convert kilometers to miles. Well, 1 mile is equal to 1.61 kilometers, which is the same as saying 1.61 kilometers is equal to 1 mile. Okay, well, which of these am I going to pick? I've got kilometers here. I want to put the same unit down here. We want to go diagonal. So kilometers is going to go diagonal, meaning I'm going to put 1.61 kilometers here in 1 mile. Kilometers cancels kilometers, and now I've got this in miles per hour. Miles on top, hours on bottom, so we're good. Now all we have to do is multiply across the top, divide across the bottom. So this is going to be 130 times 1 divided by 1 divided by 1.61. And that's going to turn into 81 miles per hour. So 81 miles per hour. And that problem is effectively exactly the same with the 60 kilometers per hour portion, right? Same process. So 60 kilometers in 1 hour. In 1 mile, there is 1.61 kilometers. Oops, hours can stay. Kilometers is going to cancel kilometers. 60 divided by 1.61. 37.3-ish. Let's call it 37.3 miles per hour. Easy peasy. Okay, let's look at another example here. 65 miles per hour, we want to know in feet per second. So we're going from miles per hour into feet per second. So 5280 feet in 1 mile, and then hours we can go through minutes and seconds. So we can say that 1 mile is equal to 5,280 feet, or 5280 feet are in 1 mile. We could also say that, I'm going to scroll up a little. We can also say that in 1 hour there are 60 minutes, which is the same as saying 60 minutes in 1 hour. We can also say that in 1 minute there are 60 seconds, same as saying 60 seconds in 1 minute. Okay, so there are conversion factors. Let's go ahead and try this out. So 65 miles per hour. I want this to be feet, and I want this to be seconds. Okay, so let's do that. Oops. Whatever. Let's do that. So I'll get rid of miles first. You can kind of do this in whatever order you want. Doesn't really matter. So I have miles here, meaning I want miles down here. So I'm going to choose this version of the conversion factor that's got miles on the bottom and feet on the top. So I've got 1 mile, 5280 feet, kill miles. And now we've got it in feet per hour. Great, okay. So next we're gonna get rid of this hours here. And again, we wanna go diagonal. So if I have hours here, I want hours up here. So in 1 hour, there are 60 minutes. We're gonna use this version of the conversion factor that's got hours on the top. Oops. Hours cancels hours. And then likewise, I have minutes here. I want minutes up here. So that's 1 minute, 60 seconds. And then we kill that. Now I've got this in feet per second. That's what we want. And now we just multiply across the top, divide by the bottom. So 65 times 5280 times 1 times 1, divided by 1, divided by 1, divided by 60, divided by 60. .3 feet per second. Easy peasy. Okay, next example. Speed of light is 3 times 10 to the 8th meters per second. What's the speed of light in miles per year? Very similar process. We want to do that conversion. So we start with 3 times 10 to the 8th meters per second. I want this in miles per year, so I want this to be miles and I want this to be years. Okay, so let's do this. This is going to be a long one, but not too hard if we remember what every step is. So first of all, we were given the conversion factor from meters to miles, which is nice. So I have, I can write that as 1609 meters in 1 mile, which is the same as saying 1 mile is 1609 meters. I have meters here, so I want meters here. So I'm going to use this version of that fraction that has meters in the bottom. So let's do that. That is 1609 meters in 1 mile. Meters kills meters. And now we have it in miles per second. Very good. Okay, so now we want this in miles per year. So we're going to go from seconds to years. 1 second is, 60 seconds is 1 minute. 60 minutes is 1 hour. 24 hours is 1 day. 365.25 days is 1 year. Now, the 0.25 here is annoying. That's actually why we have leap years every 4 years. We have to add an extra day every 4 years because the rotation of the Earth is not exactly 365 days. Whatever, you can just call it 365. I kind of don't care. The 0.25 is technically correct, but I would accept this even if you left it as 365. So for simplicity's sake, let's leave it as 365, even though actually it's 365.25 or and a quarter. Right, that's why every 4 years we have another day in the month of February to keep the planet or to keep Earth up to date with its position in space and not have it overflow. Okay, aside from the point. So seconds to minutes, minutes to hours, hours to days, days to years is going to be our conversion factor. It's a little annoying, but it shouldn't be too bad. Just keep up the technique and we'll get the right answer at the end. So seconds to minutes, there are 60 seconds in 1 minute. Seconds goes on top, minutes goes in the bottom because we want to go diagonal. Okay? Next up, minutes is here, so we want minutes here. 60 minutes in 1 hour. Hours is here, we want hours up here. So 24 hours in a day, that's 24 hours in 1 day. And then days is here, so we want days up here. 365 days in 1 year. Okay, and now we've got it in miles per year. Easy peasy. So now all we have to do is multiply everything across the top and divide everything across the bottom. So that's 3 times 10 to the 8th times 1 times 60 times 60 times 24 times 365 divided by 1,609 divided by 1, divided by 1, divided by 1, divided by 1. So we end up getting 5.88 times 10 to the 12th miles per year. So 5.88 times 10 to the 12th miles is 1 light year. This is 588 and then 10 zeros after it. So that's what? 5.88 million, billion, trillion, 5.88 trillion miles. Sounds about right. Okay, so that one involves numbers in scientific notation. If you put it in scientific notation into your calculator, you'll get it out as well. You could have also written this as 3 with 8 zeros after it, so 300 million. You'll get the same thing either way. Cool. Okay, meters per second into miles per hour. Let's do this one. 130 meters per second. I want it in miles per hour. We said earlier 1609 meters is 1 mile. So I want meters here. I want meters down here. 1609 meters in 1 mile. That gives us miles on the top, which is what we want. Per hour, seconds to minutes, 60 seconds in 1 minute. And then minutes to hours, 60 minutes in 1 hour. Minutes. Multiply the top, divide by the bottom. 130 times 60 times 60 divided by 1609 divided by 1 divided by 1. 130 times 60 times 60 divided by 1609. 290.86. Let's call it 291, whatever. About 291 miles per hour. Easy peasy. Next up, same idea. 1,100 feet per second into miles per hour. 1,100 feet per second. I want it in miles per hour. Let's get rid of feet first. So feet are here. I want feet down here. 5280 feet in 1 mile. That gives me miles up top. And then seconds to hours is the same idea. 60 seconds in 1 minute. 60 minutes in 1 hour. 1,100 times 60 times 60 divided by 5280. Comes out to about 750 miles per hour. Easy peasy. Okay, yards per hour into inches per week is a little annoying. 1 yard is 3 feet. 1 foot is 12 inches. Oh, this green is hard to see, actually. I lied to you. Let's do it in dark. So 53 yards per hour. Let's get that in feet per, in inches per week, excuse me. So yards to feet, let's do first. I have yards up here, so I want yards down here. So 1 yard is 3 feet. Go diagonal. Feet to inches, 1 foot is 12 inches. I have feet here, so I want feet here. So 1 foot is 12 inches. That kills this. So now we have it in inches. Good. Now hours to weeks. 1 hour, I'm sorry, 24 hours is 1 day. So hours here, we want hours here. Go diagonal. So that's 24 hours in 1 day. That kills hours with hours. And then finally, days. 1 week has 7 days in it. We have days here, so we want it here. 7 days in 1 week. Double check at the end. We have weeks on the bottom. We have inches up top. We're good. 53 times 3 times 12 times 24 times 7 divided by a bunch of ones. 53 times 3 times 12 times 24 times 7 divided by 1 divided by 1 divided by 1 divided by 1 is 320,544. 320,544 inches per week. Okay, 196 miles per hour in meters per second. This is similar to one that we did a minute ago. Let's do it in purple. 196 miles per hour. I wanted in meters per second. Miles here means miles goes here. So 1 mile is 1609 meters. Hours into seconds, right? So I have hours down here. I want hours up here. 1 hour is 60 minutes. Hours cancels hours. And then minutes to seconds. 1 minute is 60 seconds. Minutes goes up top because we want to go diagonal. Meters, seconds, we're good to go. 196 times 1609 divided by 60 divided by 60. Ignoring the ones, of course. 196 times 1609 divided by, times 1 divided by 1, divided by 1, divided by 60, divided by 60 again. 87.6 meters per second. Easy peasy. And then pounds per week into kilograms per second. 1 kilogram is 2.2 pounds. Pretty simple. Same idea as the last couple that we've done. Let's do this one in pink, I guess. 721 pounds in 1 week. Do this in whatever order you want. Let's do kilograms. Let's just go ahead and get it into kilograms. Pounds here means I want pounds down here. So 2.2 pounds is 1 kilogram. Easy peasy. And then kilograms per week, I want in kilograms per second. So let's go ahead and get that down. A week is 7 days. So 1 week is 7 days. Weeks cancels with weeks. Remember, always go diagonal. So weeks here means weeks here. Days. 1 day is 24 hours. Days cancels days. Hours to minutes. 1 hour is 60 minutes. Cancel, cancel. And then lastly, 1 minute is 60 seconds. All right, multiply across the top, divide across the bottom. 721 times a bunch of ones, divided by 1, divided by 2.2, divided by 7, divided by 24, divided by 60, divided by 60. So we're going to get a really low number for this probably. 721 times a bunch of ones, divided by 1, divided by 2.2, divided by 7, divided by 24, divided by 60, divided by 60. We get 5 oops, that's not a 5. 5.42 times 10 to the negative fourth, which is equal to 0.1233542. Right, 1, 2, 3, 4, yeah. Times 10 to the negative fourth is like that. And that's in kilograms per second. All right, easy peasy. See you guys in the next step. All right. Hello, what's up? It's algebra time. I moved this onto a different whiteboard so it'd be easier for me to, I'd have more space to write effectively. All right, let's take a look at this. So I've got, let's do this in red, I suppose. Let's look at our first example. We have a plus 3x equals y plus z. I want to get each of these so that x is by itself, right? So first things first, I have this 3x here that I want to get by itself. I'm going to try to get rid of this a first. So we're going to subtract this a from both sides. That will get rid of this a here. We get 3x equals y plus z minus a. To get x by itself next, this is being multiplied. The opposite of that is division, so I can divide both sides of this by 3. I get x equals y plus z minus a over 3. Okay, next up, I've got x divided by a equals 1 plus y over b. So I want to get this x by itself. This x is being divided by an a, so I can multiply both sides of this by a. And if I do that, I have to multiply everything on the right-hand side of the equal sign by a as well. So that a kills the a in the bottom like this. This a is then going to get distributed across both of these. So x equals 1 times a is a, or 1a, I suppose, plus, if I'm multiplying a fraction by a number, I'm just going to multiply the numerators, right? So a is in the numerator here. Another way to think about this is that it's a over 1, right? So we're going to multiply the top by the top and the bottom by the bottom. That is y times a, b times 1. Or in other words, it is ya divided by b. Okay, so that's how you do question B as well. All right, question C, y equals x plus a over x minus a. Okay, so we have a couple of options for how we're going to do this one. I'm going to just go ahead and do this the simplest way, I think, which is to get my x's onto the same side of the equal sign and reevaluate. So I can multiply both sides of this by x minus a. Like, let's get rid of this term in the denominator first. I can multiply this side by x minus a. That will get rid of this from this side. And then I get x minus a times y equals x plus a over here. So that is x minus a times y equals x plus a. Well, okay, I want my x's on the same side of the equal sign here, so I'm going to do that. I'm going to subtract x plus a from both sides. And I then will get x minus a times y minus x plus a equals 0. Okay, so I can distribute this y here across all the stuff. So I then get xy minus ya minus x plus a equals 0. So then what I'm going to do is move everything over. Move everything that doesn't have an x in it over here. Okay, so I've got xy that can stay. This ya here, actually, let's do it like this. This ya here I'm going to add to both sides to get rid of. Kills this. And then this here, I want to get rid of this plus a. But because this minus sign is being distributed, these are kept together. That'll get that x there, making that a minus a. So I can rewrite this as xy minus x minus a equals ya, like so. If I add a to both sides, I get xy minus x equals ya plus a. I can then pull an x out of this, right? Everything on this side of the equation is now divisible by x, times y minus 1 equals ya plus a. And then to get this x by itself, divide both sides by y minus 1. And I get x equals ya plus a over y minus 1. That's the answer. Now, this one was kind of a pain in the butt, but notice we didn't really do anything that complicated, right? Any individual step of this isn't too bad. So There are other ways you could do this too, like with factoring and things like that. Honestly, I feel like it's probably easiest to just do this multiplication and then just algebra steps through. So basically, get the x's over here, distribute out and FOIL this so that we get the YAs out of here. Then we can clump up all of our terms that have x's in them, get everything with an x on it, in it on the left-hand side of the equation, and then just do algebra to get it by itself. So that's probably the easiest way to do that one. Okay, question 4 is square root of x minus 3 equals y. This one's a lot easier than the last one. Okay, so I want this x by itself. I'm going to get this x by itself by adding 3 to the other side first. I get square root of x equals y plus 3, like so. And then, of course, if I want to get rid of a square root sign, I'm going to square both sides, excuse me. So square that, square this, x equals y plus 3 squared. If I wanted to be annoying and expand this, I could write x equals y plus 3 times y plus 3, which is y squared plus 3y plus 3y plus 9. So y squared plus 6y plus 9. So I would accept this answer. I would also accept this answer. Right, those are both correct. If you wanted to expand it out, you could. If you wanted to just leave it like this, you can. Okay, good job. Let's look at the next one. A plus x equals y plus z. That's an easy one. Right, I want x by itself. Just subtract a from both sides. X equals y plus z minus a. Easy. X plus y over y equals y over a plus y over a. Oh, that one's not too bad either. X plus y over y equals y over a plus a over y. So this one looks a little annoying, but actually isn't too bad. I want this x by itself, so first thing I'm going to do is multiply everything by a y to get it out of the denominator here. So I'm going to multiply this whole expression by y here. That cancels here. X plus y equals, y times y is y squared over a. A times y is ay, divided by y is actually just a. And then, if I want this x by itself, subtract y from both sides, I get x equals y squared over a plus a minus y. There we go. Y over x plus a equals b is this next one. Right? Yeah, so I want this x by itself on the numerator. We're going to go ahead and do that. I will multiply everything in the expression by x to get it out of the denominator here. So that gets rid of this x here. X times a, x times b. So we get y plus xa equals xb, I suppose. I want to get my x's by themselves. So I'm going to subtract xa from both sides. Right, just so that every term of my expression that has an x in it is on the same side. Y equals xb minus xa. Okay, these both every term on this side has an x in it, so I could pull an x out. So y equals x times b minus a. And then lastly, I want to get x by itself, so we subtract both sides by b minus a, or divide both sides, excuse me, by b minus a like this. So b minus a kills b minus a like that. We get y over b minus a equals x. You'll love to see it. And then last one, square root of x plus 3 equals y. So here my x and my 3 are both under the under the square root sign. Because the entire left-hand side of my expression is under an equals, or under the same square root sign, excuse me, I can just square both sides of this. So if I take this term and square it, I can take this term and square it. So that just gives me x plus 3 equals y squared. Okay, and then if I do that, easy peasy, I want x by itself, just subtract 3. So x equals y squared minus 3. All right, there we go. Okay, so next one, we're going to use with action we're using this, and I can do a bunch of variables that you can class from, and there's also very critical, you have your variables like x or v sub I, but like I said, this is you're going to change the so if all your results a here, the x is 1, the i is 13, t is 4. So I'm going to write this, x is 1, the i is 13, t is 4. When it has constant, a is unknown, and t is 4 is 4. Right, now it's all right. So if you want to say 13 times 4 is going to be something better. 20, plus 2.4 squared times 1 half. Remember that's the other first. So we'll leave the part out in this here. So this is plus 1 half times a times 2.4 squared, which I will do 5.6. Okay, so the next step is 151 equals 28.8 plus half a times 5.6. 5.6 times a 2.8 equals 2.98. Wait, that's 151 equals 28.8 plus 2.9 times a, subtract 28 from the side. 151 minus 28. 152 equals 2.9 times a, minus 2.9. Sorry. 0.21, 70. Okay, so we're going to resolve the same equation with numbers. 14.5 times 28. Okay, so negative 14.95 equals 0.5 times t plus 1 half times negative 9.8 times t squared. And so the entire, I should be entire of this slice of t. So notice here, t and t squared, and then this is right. So I have to get doing that here. Easily, it'll give me a useful solution, right? Like I can't do this because then I'll get negative 14.95 over t equals 25t minus 4.9 or 25 no t minus 1.9 t squared. Not all, right? I still have t right here. So that's the deal. Basically, there's no right to do this. Easily solve this. And so this is I would say is the right. Do you guys have some real square? Right? If you reference this, or just like put it in my Excel and then use class. Find out what each other are. So you will remember this, but I'm actually not saying how to use it. So I'm just going to look up what is give right. You can this. If you do that, you make equals 0. So that's plus 14.95 plus 14.95. 0 equals 14.95 plus 25t minus 4.9 t squared. Basically, when you just have your a equals 0, your b equals 0, your c equals 0. And if you put it in the regular equation, so now you say 4.9, b equals 5, c equals 5. And then we're going to solve that way. And b equals 0. We're going to number 14.5, b equals 5, is negative 1. And everything. 2 times t, t is 0.04, and t is negative 0.07. Let's do 0.05 and negative 0.06. So in that case, we solve that right and times in this actually because it's time. You can't have time forward. So it's possible. You never do that. But I use something from which you have easy ways to do it. Which I will do in class. Here, let's do some of those. So we have follow through. B is 0, A is 16, is 5. So that's what the f is 9, b is 0, 2 is 2, a is 16, plus x is 35. Right? So we have square 0 plus 2 times 35 is 32 times 35. Divided by 5 is 20. The f squared equals 120. Figure of 5 equals sort of 1 divided by is 33.46 over 5. That's it. Result, so we follow through. As 90g is 9, h is 16, x is 4, x is 120, 5 is 5. Wait. So it is 90. As 90 times g is 9, h is 16 plus 1 half k is 5, x is 4 plus f is 140 times t which is 5. All equals 1 half as 90 times the square root. Right, so we're going to do this. Let's just do the pieces. So we're going to plus 9 first. 16 is 14.1. Or 1 plus 1 half times 5 is 2.5. 4 is 16. Something like that. Plus 2.5 over 40 is 490. Equals half 90 times 5 times cool. So now we decide 14.1 plus 2.5 times 16. 2.5 times 16 is 40. So 14.1 plus 40 plus 40 is 45 squared. 14.1 plus 40 plus 40 is 141. Equals 45 squared. That is 45. 141 by 45 is 12.1 plus 12.1 equals squared. And that's 90 squared. So we throw the side. Square root of 12.1 is 3.4 times 45. Alright, next problem. Tau equals p side. Good library here. Not any larger rank outside of the universe. So we're going to fast. We have to use which if you want to tau. This tau is going to be easier. Right. So tau is p side. So tau follow through. 15 is 9. It is primary. Or power 3 into AI based on so the tau equals 15 times 9 times sin 45. Right. So as I know sin 45 is 15 is 0.7 so 15 times 9 times 0.71. 1 minus 15 and there we go. 9.5 tell me about 9. Easy. Right. Next question. M1 d squared r equals g1 2 over r squared. M1 and 2 is variables. Sometimes in the have even the one object and 1 gas and 2 gas. So what is it? 1 2 first right. Right. So now we're going to take it. Right. So let's start this. Yeah. We're going to 2 and g r and v r is. Okay. So let's do this. I do not 1. So m1 times v squared which is 1 times 10 to the 4. R is 1.7 times 10 to the 8 equals g which is 6 times 10 to the 11. M1 is unknown and 2 unknown and r squared is 1.7 times 10 to the 8. Sorry. So it's a little tricky. And it's usually like, oh, how do this? And it's here. Right. But you just like, okay, M1 and 2. How do you know M1 and 2 and M1? And it's important. We don't actually, I'll tell you guys right. Okay, so here's what we got. There's M1 side and M1 side, right? And this is all the way to this is all the way to so this is not true. This is not true. And there's no addition, right? This is just all one term. I can find M1. We're getting M1 here and M1 here. So basically because of this, I know M1 since every term here has M1 I can remove from each other. And this is M1 cancel. So you know what we'll think out. And then there, it's pretty straightforward right? So if you want to be fancy, you do the rules. But I'm going to do the now. So it's together. And it's together. So if you cancel 4 5 we just equal to the parentheses. 1 times 10 to 8. You're getting 1.32, 1.52. Yes, I'll do 1.5 times 10 to the 4 equals whatever you're doing. We're actually using this further. So I'll hear this from the top further. So 6.7 times 10 to the 11 times 2. 9 times 10 to the square. So I'll here 1.7 times 10 to the 8 power. For that. Then we go 2.9 times 16. Okay, and now all I have to do is solve this 2. Here's the number, right? Minus 10 to the negative. So I just break it out now. With number 1.5 times 10 to the 4 equals 6.7 times 10 to the 5. Divided by 2.89 times 10 to the 16th plus 6. 2.2 times 10 to the 4 and 2. And then lastly, solve the 2 times 10 to the 6. So that's 1.35 times 10 to the minus 4 power divided by 2.2 times 10 to the minus 27 power. Divided by 6.136 plus 4 times 10 equal to 2. Right, so I'm a little tricky, just because of this thing, and it's okay, but after you guys have to do just make sure all the numbers are right. Right, so this one is a little bit more complicated. I was going to have a forces, F, G, F, D, and last round I'm going to do answer. F, G, F, D are all the forces. F, that for lowercase for whatever force, we're going to use okay, so let's take this. 0 equals F minus F. Here are the variables above it. So all I'm going to do is this. Wait, I was going to do this number. Then I'm going to as well. I'm going to just copy and paste the numbers. Right, so you're that's a number. Like, okay, now I'm going to okay, let's find it out. So I'm just going to all these equations in it, substitute them for their these very variables. Okay, so I say 0 equals f d is w divided by g minus f which is mg mu times the sine of theta minus mg times the sine of theta minus fd which is 1 half rho c sub d a d squared. For rho c sub d for coefficient a for surface area, v for squared, for equals squared, and ft d and fg is mg sine theta for surface area minus fd for minus surface area. I'll define this more. I'm sure we would. Alright, so here we go. Now there's one. You want to also use solve g to the limit. So you like do a little bit of the that's okay. So any 140 kilograms is 0 equals square line. W for 900, d is 150, minus n is 140, g is 9.8, mu is 0.4, cosine of 60 degrees, minus mg is going to be 140 times 9.8 times sine theta, so that's sine 60 degrees, minus all that stuff in the equation is 1.3 as well, minus 1 half times 1.3 for rho, times 60 times 0.6, times a is 21, and then times b squared, result of b. Okay, so now we're going to do this individually. This is a couple of actually. Don't do this. I'll do it. So we're going to go just gonna line. It's minus 1 times 0 4 times 0 number 0 1 times 0 5 times 0 4 times 3. So 0 4 minus sin 60 times 3. The sin 60 is the 0.866 Oh, I'm going to do 0.87 times 3 is back again. 0.87 times 3 times 3. I'm going to do 193.6. I was going to go close to 94 minus 93 times 6 94. And then minus drag, which is half of 1 times 0 times 1. 1.3 times 0.6 times 0.5 times 1 is 8.19 8.2 times 0. Wait, now we're going to do solve at this equals 0. And minus 6 plus 24 actually let's do easier, right? So 20 minus 4 minus 1 minus 2. 0 equals negative 1,442 minus 8.2 times 2. Okay, so solve for add 1442 both sides. We get 1442 equals negative 8.2 squared. Solve for we get divided by 2 divided by negative 2 is 175.9 equals v squared. Okay, so you're wrong. You're getting this. Okay, and that's how you can say I'm just here to show you second alcohol with home shows random numbers 0. So usually, when I get this wrong, usually I'll take time to sure the next time. Lots of times you are trying to equal 1,000 miles an hour. I want to make from 4 last hours. Sometimes I'm going to go to and that means we're always not possible to do anything answer. And I chose weird numbers. And that's what I mean. So we're going to do this which means it's not possible to do. So the answer, if the answer for all that's wrong, separate numbers wrong. Of course, you're asking that. And I'm going to take the next thing I mean. How many mistakes is the we're all this. Find the answer, and then tell you the next thing So we know 175.9 equals v squared. It's sort of beside v is again for negative. I don't want you to do that actually. To that level. So v equals 13.3 I. And of course, we're doing this never right. Your answer never. So this is the number. And that's fine. If you this then usually I'll have to correct for any of the but if you never wrong as well, I'm not going to wrong. I'll look for you and of course you and I'm going to start okay, so this is the number. I just made it. Cool. I'll see you guys.
Okay, so in this next section, we have a series of equations, and uh, we can actually solve these in a handful of different ways. You'll get the same answer no matter how you solve them. Some ways are a little bit easier to solve them than others, and honestly, some ways to solve these will be easier uh, based on the exact numbers that we're dealing with too. So I'm going to solve these in a combination of different ways. You should be able to get the same result no matter what, though. So a series of equations is pretty simple. It just means that we've got a couple of different statements that must be true. If we have separate statements that must be true, we will be able to combine them. So the most straightforward way of combining them is by just doing what we call in matrices row operations with them. Basically, we can do basic arithmetic with these equations um, and get them to yield a single variable for us. So for instance, looking at this first one, I have 2x minus 5y equals negative 25. 4x plus 5y equals 35. So I can, because these statements both have to be true, I can combine these together. And so the easiest way to do this in this case is to just add them, right? Um, so 2x minus 5y equals negative 25 plus negative 4x plus 5y equals 35. When we do this, 2x and negative 4x is negative 2x. Negative 5y and positive 5y is 0y. Negative 25 and 35 is 10. Okay, so now by doing this, I have another statement, which is negative 2x equals 10. Okay, doing this, I can now just go ahead and solve this for x. When I do so, I get x equals negative 5. And now, because this statement must be true as well, I can just plug this back in over here and solve for y as well. So if x is equal to negative 5 in this case, I can say that 2 times negative 5 minus 5y equals negative 25. 2 times negative 5 is negative 10 minus 5y equals negative 25. Add 10 to both sides, and we get negative 5y equals negative 15. Divide both sides by negative 5 to solve for y. We get y equals 3. So this first one is x equals negative 5 and y equals positive 3. Here. And because I used up some space for that, I'll go back and erase all this. Okay, next example. I'm going to show you another way we can do this. So because these statements are both true, that means I can do a substitution of one of these for a variable and then plug it into the other one to solve for that variable. So here in question B, I've got x plus 2y equals negative 1 and negative x plus y equals 3. I'm going to solve one of these for a variable and then plug it into the other one. So it doesn't matter which one I choose. Let's just go ahead and do this one, I guess. Negative x plus y equals 3. I'm going to solve this for y. So to get y by itself, I can add x to both sides. So I can say y equals 3 plus x. Now, this is true. And what this means is I can put this into the first equation here and now replace my y with this function here that has an x in it. In doing so, I can get this to be only x's and numbers and then solve for x. So let's do that. I get x plus 2 times y, which we said is 3 plus x equals negative 1. This 2 gets distributed across both these guys here. So we get x plus 2 times 3 is 6, plus 2 times x is 2x equals negative 1. And so we get x plus 2x is 3x plus 6 equals negative 5. Subtract 6 from both sides. Negative 1. I don't know why I wrote negative 5 there. Oh, probably because I moved the 6 over in my head prior to that. That's strange. That's a weird mistake that I made. Sorry, ignore that. Oops. So subtract 6 from both sides. We get 3x equals negative 7. Divide both sides by 3. X equals negative 7 thirds. Or, negative 2 and a third, or whatever, however you want to do it is fine. So now that I know x equals negative 7 thirds, I can go back and solve one of these expressions for y, knowing what x is. So x is negative 7 thirds, y, as we said over here, is equal to 3 plus x. X is negative 7 thirds. So y is 3 plus negative 7 thirds. That's going to be y equals positive 2 thirds, I think, right? Because 3 is 9 thirds minus 7 thirds is, yeah, positive 2 thirds. So x is negative 7 thirds, y equals 2 thirds for that one. And notice you could have done the same thing you did for this one, the same thing I did for part A on that as well. You would get the exact same answer if you do so. So, like I said, all of these you guys get to pick whichever method you want and it'll work.
Okay. So let's take a look at this one. This is a system of equations. It's got 3 parts to it. It is going to be similar to the last one that we solved, but in a couple of different steps. We're effectively just going to have to do the same kind of stuff that we did in the last couple problems, but multiple times. So the first thing we're going to do is we're going to try to pick a variable to eliminate. There are a couple of ways you could do this. You could pick any variable you want. I'm going to just do t here because I think it's easy. So I'm going to take, actually, before I start, let me go ahead and label these equations 1, 2, and 3, just so it's clear which one I'm talking about. So I'm going to take equation 1 and equation 3 and combine them, because here I've got plus 4t, and here I've got minus 4t. So if I add these two together, I'll naturally get 0t as a result. So I can take 4r minus 4s plus 4t equals negative 4, and negative 3r minus 3s minus 4t equals negative 16, and then add those two equations together. 4r minus 3r is 1r, minus 4 minus 3 is 7s, 4 and 4 make 0, and then negative 4 and negative 16 is going to be negative 20. Okay? I'm going to nickname this equation A just so I can refer to it back to it. And equation A is made of 1 and 3. Okay, so next we're going to take equations. We're going to take 2 more equations. We want to eliminate t from another one. So we're going to take 2 and mix it with either 1 or 3, since we've already used 1 and 3. Basically, when we do this, we want to make sure we're getting a mix of all 3 of these equations. So I used 1 and 3 to make equation A down here. I'm going to use 2 and either one of the other 2 to make another. I'll use 1 for the second one. I'll do this in red. So here I've got 4r minus 4s plus 4t equals negative 4. And here I've got 4r plus s minus 2t equals 5. Now, the problem with this, as you can see, is positive 4 and negative 2 do not 0 make. So what we're going to do is we're going to multiply the entire bottom equation by 2 in order to get that negative 2 to a negative 4, and then we can cancel those. So I multiply the entire bottom by 2. that 5 will become a 10. That negative 2 will become a negative 4t. That s becomes a 2s. That 4r will become an 8r. And now we're talking. So all I got to do is add these two equations together, just like last time. 4 plus 8 is 12r. Negative 4s plus 2s is negative 2s. 4t and negative 4t is obviously going to be 0t, which was the point. And then negative 4 and 10 times 2 is 20. That is going to be 16. Or I'm sorry, I already did the times 2. Negative 4 times 10 is plus 10 is going to be positive 6. Cool. So now I've got equation A, and I'm going to call this one equation B, which is made of 2 plus 1. Okay, great. So now that I've got these two, I'm going to combine these and do the same thing to eliminate either R or S, and then we're down to one variable. So I'm going to take equation A plus equation B. Equation A is 1R minus 7S equals negative 20. I just dropped the plus 0t there. B is going to be 12R minus 2S equals 6. And now we're going to get eliminate one of these variables the same way we just did. You have options for this. I'm just going to go ahead and multiply the top by negative 12. That way I can get all my R's and S's together. So when I do this, I get plus negative 12 times 7 is 70, 1484 equals negative 20 times 12 is negative 20 times negative 12 is going to be positive 240. Lily, stop. My cats are bullying each other in the background. Forgive me. Okay, so with that being said, now we've got negative 12R plus 84S equals 240. I can then take this and add 12R plus negative 2S equals 6. When we do so, the R's cancel. We get 82S equals 246. Divide both sides of this by 82, and you get S equals 3. Once we have S equals 3, once we have one of our variables, this whole thing becomes a lot simpler. We can then take this S equals 3 and go back to our original two equations that we removed variables from. So I'm going to take A and B, and I'm going to add them together again. Actually, sorry, either. Okay, so now that I've got S equals 3, I'm going to go back and put this into either equation A or B. These both have a t missing from them, so I can solve for R because those only have two variables. So let's go back to equation A, the way we have it, and that is R minus 7S equals negative 20. Okay, so that's R minus 7, we said S was 3, equals negative 20. Negative 7 times 3 is negative 21. So then R minus 21 equals 20. Or sorry, negative 20, excuse me. If I add plus 21 to both sides, I get R equals 1, and there we go. You'll love to see it. Now finally we have one last step. Let's just go back to one of our original equations. Since we know that R equals 1 and S equals 3, we could just plug them into any of these. I'll just do the first one, doesn't matter. That's 4 times 1 minus 4 times 3 plus 4 times t equals negative 4. 4 times 1 is 4. 4 times 3 is 12. 4 times t is 4t equals negative 4. 4 minus 12 is negative 8 plus 4t equals negative 4. Add 8 to both sides of this. 4t equals positive 4. Divide both sides by 4, we get t equals 1. So the answer to this is t equals 1, R equals 1, S equals 3. right? Not too bad once you know what you're doing. It can be kind of a pain, but the actual math isn't too tough. Okay, so similar to the last one, we're going to do a similar process. This is just a series of 3 equations. We're going to combine equations 1, 2, and 3 into 2 separate ones that will each remove a variable. Okay, so I'm going to pick a variable to remove. You can choose any of them. Let's do Z first. Z is an easy one to do. So I'm going to start with 2 and 3, combining those two, because notice I've got a minus 2z and plus 2z. If I add those together, it'll get rid of z. So equation 2 plus equation 3, which I'm now going to name equation A, is negative 2x minus 5y minus 2z equals 12, and negative 2x plus 5y plus 2z equals a 4. And when we do this, we get negative 4x plus 0y plus 0z equals 16. And solving this, we can actually already go ahead and eliminate 2 variables at once with this because of how these are set up, which is nice for us. Negative 4 from both sides, we get x equals negative 4. 16 divided by negative 4 is negative 4. Wonderful. Okay, so now that we know what x is, we can put it into another one of these. But in order to do so, we got to remove another variable first. So I'm going to make another equation. I'm going to call it equation B. And I'm going to make it by adding 1 and 3 together. So I'm going to do, that's going to be negative 4x minus 5y minus z equals 18. And then this one is going to be negative 2x plus 5y plus 2z equals 4. Okay, notice my y's actually are going to cancel themselves here automatically, which is nice. That's what we want. So I'm going to go ahead and add these two together. Negative 4 minus 6 is negative 6x. 5 and 5 makes 0, or 5 and negative 5 makes 0, excuse me. Minus z and plus 2z is going to be plus z. 18 and 4 is going to be 22. So negative 6x plus 0 plus z equals 22. Now, we know what x is. X is negative 4. So negative 6 times negative 4 plus 0 plus z equals 22. Negative 6 times negative 4 is going to be positive 24. And then to get z by itself, we subtract it from both sides. So we get z equals 22 minus 24, which is negative 2. And of course, now that I've got negative 4, or now that I've got x and z, I could solve for y. I can solve for y by putting these into any of these equations that I want. Let's go ahead and do it in the top one. Doesn't really matter. So that's negative 4 times x, which is negative 4, minus 5y, which we're going to leave as 5y, minus z, which is negative 2, equals 18. Negative 4 times negative 4 is positive 16. 5y will stay like that. Minus negative 2 is the same as a plus 2, equals 18. 16 plus 2 is 18. Minus 5y equals 18. Right, so we get 18 minus 5y equals 18 here. And then if I do minus 18 for both sides, I get negative 5y equals 0. Minus 5 divided by negative 5, we of course get y equals 0. Okay, so we end up with y equals 0, x equals negative 4, z equals negative 2. Okay, so for this next one, we're going to find the distance between some points. You might have learned in math class that the distance between 2 points can be found with the formula, d equals the square root of x minus x squared plus y minus y squared. And this is true. This formula will work. Just keep your x's and y's consistent, right? The x of one point, the y of the other point, the y of one point. So like this and this x and y would both be a, and then this and this x and y would both be d. You'll often see it written also as like x1 minus x2, y1 minus y2, just for points 1 and 2, whichever one you want. So we can do this, and that will yield the correct answer here. So let's go ahead and do that. A's x is 8, D's x is 5, plus A's y is 7, D's y is negative 3. There we go. All right, so 8 minus 5 is 3. So we get square root of 3 squared. Plus 7 minus negative 3 is positive 10 squared. 3 squared is 9. 10 squared is 100. Square root of 109 is going to be like 10 point something, 10.1 probably. Take out my calculator, I'll round it to a decimal point. 10.4. 10.1 was a little bit of an undershot estimate. So 10.4 units is our distance here. So really quick, I want to show you guys what we actually just did. What we effectively have done is found the distance by using the Pythagorean theorem. So let's think about this. If I'm going from D to A, right, I can go in this diagonal line, or I could equivalently go as two straight lines, right? I can go from here to here by going 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6, 7, 8, 9 up to the top. 10, actually, excuse me, I missed one. Right? Notice that gives me the two sides of a right triangle. This side is 3, this side is 10, just like we found down here. How do I find the hypotenuse of a right triangle? A squared plus B squared equals C squared. So that's A, that's B. I could find C by using the Pythagorean theorem. So that distance formula effectively is just turning my diagonal into two straight lines and finding the hypotenuse that way, which is something that we are going to be doing quite a bit of in physics. In fact, anytime we deal with two dimensions, we're going to make them into two straight lines. Okay, the next one asks for the difference between B and C, same idea, but this time I'm going to use the geometric method since counting squares is a little bit easier. So that's negative 2 to negative 7, 1, 2, 3, 4, 5 here, and 1 is going to be, or the y, excuse me, is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, sorry, I miscounted. Right? So now all I got to do is find this side of the triangle. A squared plus B squared equals C squared, so that's 5 squared plus 4 squared equals C squared. 5 squared is 25, 4 squared is 16, C squared is C squared. 25 plus 16 is 41 equals C squared. Take the square root of both sides, and we get C equals the square root of 41, which is going to be 6 and some change. $6.4. Excellent. Okay, our next question is asking us to find the midpoint between these 4 points. So the midpoint is actually pretty simple. It's basically if I were to average the position of all 4 of these points, where would I get? So a good way we can eyeball this is, let's draw a little, connect these points with lines here. Where is the middle of this shape? It's kind of like around here-ish. So we should expect to get a point kind of in this range when we do this, the mathematical way. So because this is the average of all of our points, the way we find this point here, midpoint, is really easy. All we got to do is take the average of these 4 points, x and y values. So that's all of the x's together, 8 plus negative 2 plus negative 7 plus positive 5. That's 6, that's negative 1, that's 5, that's 4. So our x coordinate is going to be a 4. Then there were 4 points, so we're going to divide that by 4. So our x coordinate is 1. right? Remember how you take an average? You add everything together and then divide by the number of entries. Here we added all of our x coordinates together. There are 4 points here, so I divide by 4. And then similarly for y, we're going to do the same thing. 7 plus -1. Sorry, that's +1 actually. Plus -3 plus -3. 7 plus 1 is 8 minus 3 minus 3 is 8 minus 3 minus 3 is 2. Divided by 4 is 1/2. So our midpoint here is 1 comma 1/2. So that's going to be like right about there. And notice that falls within our range of eyeballing it. So that sounds good to me. So for question 4, it asks what the total distance Steve covers during his trip if he walks from A to B. Oops. If he walks from A to B to C to D. So all we got to do now is find the distances between all these points like we just did in the previous one and then add them together. It's probably the easiest way to do it. So for A, I'm going from 8 to -2, so that means I'm going to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. 7 down to 1 is going to be 1, 2, 3. Oh, I went 11 actually. I went 1 too far. Oh my gosh. So 7 to 1 is going to be 1, 2, 3, 4, 5, 6. Like so. So then this can be found with 10 squared plus 6 squared equals c squared. That's 100 plus 36. Square root of 136 is going to be between 11 and 12, probably closer to 12. (136) is going to be 11.66. Let's call it 11.7. All right, same thing over here. -2 to -7 is 1, 2, 3, 4, 5. And then 1 down to -3 is 1, 2, 3, 4. Like so. And so to find this, it's going to be 5 squared plus 4 squared equals c squared. 25 plus 16 equals c squared. Oh, I'm sorry, we did this already, duh. I should have written that question a little differently, sorry. So c is the square root of 41, which we said earlier came out to... I'm embarrassed that I erased it. 6.4. So this is 6.4. And then here, actually, this is just a straight shot. So we don't even need to do any trig here. -7 to +5 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total distance is just going to be 11.7 plus 6.4 plus 12. That's 17, 18.1 plus 12 is 30.1. And that's whatever units this is in. I don't think I gave it units, meters, miles, whatever. 30.1 of whatever units our grid is. 30.1 squares, effectively. All right, wonderful. Wonderful job. Okay, so our last question here in this section asks us to describe the distance between the origin and point A as a straight line and an angle. This question might seem a little bit esoteric. It might be kind of hard to understand at first, but the actual thing I'm asking you to do is very simple. Point A, we can get to as two straight lines like we said before, right? We can treat this line like part of a right triangle. So we said earlier that this was, or actually we didn't do this exact calculation. We did it to point B, not from the origin. But anyway, this side is 8 units long. This side is 7 units long, right? I could describe, instead of going, to the right and up to get from here to here, I can just go diagonally. So I can treat this like it's a right triangle, right? Because this is going to be the equivalent of going like this, stopping, and then going like this. So I can treat this like it's a right triangle. And so I can find this angle and this distance, and then we're good. So the distance is going to be Pythagorean theorem again. C squared is equal to a squared plus b squared. I read that backwards. It's still correct, but if I triggered your OCD, I'm sorry. 8 squared is 64. B squared is 49. Sorry, 7 squared is 49. 64 plus 49 is going to be 103. So c squared equals 103. Right? Did I do that right? Yeah, I did. Square root both sides. C is going to be square root of 103, which is, oops, 10 point something. 10 point low number. 10.14. So that's our distance. Now for the angle, we can do this using an inverse trig function like we did during the trig section earlier. So we could say that theta equals, pick your favorite trig function. Let me just use tangent. The inverse tangent of opposite over adjacent. The opposite is 7, the adjacent is 8. And if you put tangent to the negative first of 7/8 into a calculator, it will tell you about 0.71 radians, or about 41.2 degrees. Let's put it in degrees. And there we go. Okay, welcome to the last part of this. We are now going to look at some graphs. This last section is going to be a lot less about math. Well, a lot less about math in the sense that we're not going to be calculating anything. We're going to just kind of be eyeballing these graphs and taking a look at what they mean, and kind of figuring some stuff out with them. Being able to read graphs is an incredibly important part of any science, really. Okay, so let's take a look at this. The efficiency of an electrical engine, E of C, E is a function of C, can be represented as a function of the input current. E of C is shown on the graph below and can be expressed as a percentage of the input current, which is shown on the graph below as C, the input current in amperes. Answer the following. Okay, so before we do anything, let's just take a look at what we're looking at here, right? What is this telling us? This axis here, so we're dealing with an electrical engine, right? That engine, you obviously are going to put electricity into, and it's going to spin. So this is efficiency, right? The efficiency of the engine is going to be how much it spins. And then this axis here is going to be amount of electricity put in, the current. This is a bit of a simplification, obviously, but it'll help us to kind of just get an idea of what's going on here. Obviously, if I put no electricity into the thing, it's not going to do anything, right? So if it's under 0.5 here, this area here represents my motor's not spinning because it doesn't have enough electricity. As I increase the current, obviously, I'm going to get more and more and more and more and more and more and more spinning out of this. And then after a point, it becomes less efficient because I'm wasting more electricity and it can only spin so fast. So its maximum speed, its maximum efficiency is kind of noted up here, right? Because anything past this, I'm pouring more electricity into it, but the engine cannot spin any faster. And slash, or we're, getting losses to electrical resistance, damage from heat, and that sort of thing. Okay, so maximum efficiency of the engine and what input current can it be found is pretty easy. I'm looking for maximum efficiency. This is the efficiency, my y-axis. So where's my y-axis highest? It's going to be here. So maximum efficiency is going to be 50, looks like. And at what input current can it be found? Well, 50 is here about at 1, right? Yeah, it's like here. I'll call it 1. The actual tip of this graph is slightly over the edge, but whatever. I would, if this was like an exam question, I would accept 1. I'd accept 0.9. I'd probably accept 1.1. You get the idea. Basically, if I can tell that you're reading the graph correctly, you eyeballing the number, I'll give you some grace on. So 50 is the maximum efficiency, and 1 ampere is the input current. Okay? If the input current is 2.5 amperes, what's the efficiency of the engine? And then given this value, what would be the effective output current of the engine? Okay? So, here's the idea. Input current's 2.5 amperes, that's down here. Where is the graph at 2.5 amperes? It's here. So at 2.5 amperes, it's here, that's like 15-ish, so the efficiency is 15%. And if the efficiency of my engine is 15%, that means 15% of my current is being used, so the effective output current is going to be 2.5 amperes times 15%. Right, the efficiency is effectively a measure of how much of the energy, or in this case the electrical current, of your engine is being actually utilized and how much is being wasted. So if I'm 15% efficient and I'm putting 2.5 amperes in, 2.5 times 15% will give me my answer. So 2.5 times 0.15 is 0.375. And that's in amperes. Okay, and then what are the minimum and maximum input currents that will make the engine still function? Well, the engine obviously doesn't function if the efficiency is negative, right? It stops functioning at 0. So where's my efficiency 0? It's 0 here, and it's 0 here. So that looks like what? Like 0.4 and 3? About 0.4 amps. And that one's pretty plainly 3 amps. And there we go. Not too bad. Let's look at the next graph. The graph below represents a student's success selling home-made bracelets over the summer. The function, P of W, represents the profit in dollars that she's made as a function of the weight in kilograms of bracelets that she's sold. Answer the following questions. What weight of bracelets will the student have to sell in order to break even? And what part of the graph shows us this? In this situation, please describe the y-intercept as negative, why the y-intercept is negative, and please describe the information of this graph as a function of profit P, the weight of bracelets W, and constants. Okay, so first things first, you probably look at this immediately and be like, oh, this is linear, right? It's a straight line. So that tells us a couple of things. But first, let's start by getting a lay of the land. So here is the amount of bracelets sold. And here is the money made, or the profit, right? So when we break even, right, our profits are 0. That should make sense. If you spend money to get into a business, you're going to start in the negative, right? You make a down payment. This person had to buy all of the string and all of the beads, get the materials for the bracelet. So you're going to start in the negative profit here. That actually answers question B, why is the y-intercept negative? Because when you're starting a business, when you don't have anything to sell yet, you've got to invest some money in making, in getting materials. So I would say here that they had to pay for materials. And or labor in this case too, if they were hiring people. But in this case, it's probably one person. Doesn't matter. So now, profit is 0. You've broken even once you've made back the money that you've spent. So here is where we break even. So that looks, I don't know, about maybe halfway between 30 and 40. Call it 35 kilograms. Of bracelets. 35 kilograms of bracelets is insane. This question is insane, actually. It has kind of the same energy as those math problems from elementary school where like a kid goes to the supermarket and buys 80 watermelons. This kid is selling 35 kilograms, which is like 80 pounds of bracelets. It's a lot of bracelets. Anyway, sorry. The last part of this question asks us to find a function. So basically, we want to find the equation of this line. In terms of the profit, the weight of the bracelets, W, and constants. Okay, so the equation for a line is y equals mx plus b, where m is the slope of your line, b is the y-intercept, and y and x are your input, your values for y and x. So you can input a y or you can input an x and get the other value from this equation here, is the idea. So here we want to know, what is our y-axis? Our y-axis is profit, so that's going to be a p. M is the slope of this line, which we can calculate. Calculate the slope of a line by choosing any 2 points and using the slope formula on them. To make this easy, I will choose, I should not have erased it, this point and this point. So this bottom point down here, I'm going to call that negative 250, probably. And it's the y-intercept, so it's 0, comma, negative 250. And then over here, the x-intercept is 35, comma, 0. So our slope formula is delta y over delta x, changing y over changing x, or rise over run. So how much do I rise over how much do I run? This over this. Okay, so that's going to be 0 minus negative 250. You put these in any order. I'm going to put top point, bottom point. So 0 minus negative 250 over 35 minus 0. 0 minus 250 minus negative 250, excuse me, is going to make that positive. So we get 250 over 35. 250 over 35 is like 70. It's going to be 4 and some change. I'm sorry. Duh. It's going to be 7 and some change. 7.14. Wait, there's our slope. So that goes in for M. X is going to stay as an X. Or in this case, because X is representing the weight, we'll make it a W. And then B is just our y-intercept, which is negative 250. So the equation to this line is P equals 7.14 W, right? Because P is Y and X is W, plus negative 250. And there we go. Okay, next question. A few students went on a short road trip, driving due north from their hometown. They put a temperature probe on top of their car, and they drive north. This function represents the temperature outside of the car in degrees Celsius relative to the distance driven north from their hometown in kilometers. Answer the following. At what distance away from their hometown was the temperature the highest? What about lowest? That's easy. We're just going to look for highest and lowest temperatures on this graph. Right, this is temperature, this is distance. So, they drive, the temperature goes up, the temperature goes down. This is representing the air temperature outside the car. So highest temperature and lowest temperature is going to be easy. That's just going to be the top and bottom point of our graph. Looks like here and here. That's the top, that's the bottom. 16 degrees Celsius was the highest, looks like. And then, what, negative 4 maybe? Yeah. Negative 4 degrees Celsius was the lowest. Now, at what different distances away from their hometown was the change of the temperature the most extreme? So we're looking for change in temperature, meaning how quickly we're able to drop temperature. We're looking for the part of this line with the steepest slope. I say drop or spike, right? Increase or decrease. If we're looking for change, that's going to represent the slope of this graph. The sharper the slope of this graph is, the faster the temperature is changing. This represents a much bigger temperature change than this, for instance, right? So the sharpest points of this graph to me look like here, and like maybe here. You could make an argument for other spots. You're kind of eyeballing it here. If this were like an exam question, I'd be pretty generous as long as your thought process is right, probably. So I'm going to approximate this. At what distances is the spike the most noticeable? Looks like maybe here, call it 95. So about 95 kilometers. Similarly, here between 160 and 180, about 170 kilometers. That's what the steepest slope is. Sounds about right. So come up with a situation that would describe the shape of this graph. In other words, what could possibly have happened during the road trip that would explain the shape of this graph? There are a million correct answers to this question. I just asked it because I want you to, kind of think about it, right? So there are plenty of examples for things that could happen. All this tells us is that for the first, maybe 50, notice for the first 50, this line is kind of steadily going up. So the temperature is going to increase here for some reason. Then we kind of go down a little steadily. Then we kind of go down pretty fast. So we decrease and then we spike here. And then we kind of level off a little bit. We get colder. We round off and we start warming up. Again, with a little dip in the back. So there are plenty of explanations for this that you could come up with. One that I think makes sense is that maybe they started driving early in the morning before the sun was all the way up. And so as the sun rose, their car heated up a little bit. Right? As they're driving more and more, the top of their car is getting warmer and warmer because the temperature probe is getting hit by sunlight. Then maybe some clouds come in or it rains or something. In fact, raining would make really good sense with this because here, clouds come out, they cover the sky before it starts raining, it gets a little bit colder. Then it starts raining, water hits that temperature probe and cools it way down, so this spike comes in. Then we, stabilize a little bit, we dry off, we warm up a little, and then we start to heat back up. That's a perfect example of what this could work. But, this is a representation, right? There's a lot of different ways you could answer this question. Some dude with an ice pack comes along and duct tapes it to the top of their car, right? I would accept all kinds of different answers to this. Okay, the last question of the entire thing. We're going to look at this last graph, and we're going to mark the spots on this graph where the slope is highest, positive, highest, negative, and 0. So similar question to where it was last time. The slope is highest where the line is steepest. To me, that looks like right here, kind of. And highest negative looks like on this side, maybe. Like this is probably steepest. Now 0 is an interesting question. 0 slope looks like a flat line on a graph, generally. So where is the slope 0 on this? The slope is going to be 0 on these spots where it goes from being positive to negative. If you think about this, the thing, the value is increasing, decreasing. At a spot right here, it is stable for just a moment. Right? The slope is here positive, the slope here is negative. The slope right at the top of this graph is 0. It goes from, another way you can think about it is it goes from this to this. Right here in the middle, it's between those two. So our slope is going to be 0 at the tip of a curve, effectively, is what I'm saying. So our slope is 0 here, 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 and our slope is going to be 0 up top in this part that got cut off a little. Okay, now, very last question. If we assume the bottom left-hand corner of this graph is 0, 0, which of the following equations is the only one that could describe this function? Describe y in your own words. Okay, so let's think about this. If this is 0, 0, and we're doing classic Cartesian coordinate plane, that means that this is positive and this is positive. That matters as we do this. That means that we can only get positive values for y given positive values of x. Okay, so let's take a look at our options here. Option 1, y equals 26. This cannot be correct, right? And it's because if there's no x in this statement, the graph of y equals 26 is going to be a straight line. No matter what your x is, because there's no x in this equation, y will always be 26. So it's going to be a straight horizontal line. So it cannot be this question here. Y equals 16x minus 30. Okay, this function has, there's a couple of ways to tell this. Number one, you might be able to immediately look at this and tell that it's linear because it's in the format y equals m of x plus b, right? It's got an x to the first power with, a constant in there. So this graph would look linear like this, but there's actually another way to tell just given this information too, if you didn't know that off the top of your head. There's a negative 30 here. So let's say x is 1, right? That's going to be 16 times 1 minus 30 is negative 14. I cannot get a negative from this because both of my y and x axes are positive. So this one doesn't work for both of those reasons. This next one, y equals 14x squared plus 7x plus 300. This, if you know the shape of graphs, that's going to be a curve like this, an exponent. It's closer to what we want. That squared term does make it have a curve in it, but think about it. If I only have positives here, this number will only ever get higher, and so I won't get zigzags. This graph goes up and down and up and down and up and down. Because it goes up into down, that means there has to be subtraction in here somewhere. Hopefully that idea makes sense. Right? Basically here, x can only ever increase given, or sorry, y can only ever increase given positive x's. If I, make x and, if I make my x's higher, my y must get higher because this whole thing is positive in addition. So that can't make this graph because this graph goes up and down. And finally, our last thing here, notice we've got a minus term. That means that at different values of x, we can zigzag and get different ups and downs here. Okay, well, thank you for completing the assignment. I'll see you guys next time.